How do we move from MATLAB and into simulated real-world systems? We will go from kind of lines of code to what does that mean from a simulation perspective. So what we're going to be doing now is we're going to go through the last step that we did, and if you haven't seen the video regarding the uncertainty that was put in for a pump and how that relates to its power versus the time of day that it makes it more efficient, I suggest you watch the video before this one. But what does that mean, right? What does that mean to go from what we have here, which essentially runs, so if I were to kind of run this again, what it gives us, it gives us an indication. Let me close this. It gives us an indication of what are we trying to achieve, what does an uncertainty do for a pump. But the next question would be, how do I go from this specific lines of code, which, to be fair, it's quite short, right? 50-40 lines of code is pretty short for MATLAB script. I've seen MATLAB scripts up to 500, 600, 700 lines. It becomes a bit cumbersome if a MATLAB code is too long, but essentially 40 lines of code is pretty short. So let's fire up Simulink. When you open up Simulink for the first time, what it gives you very clearly, it gives you an ability to figure out that you can either have a blank model, you can start in different places, but essentially what we want, for the sake of at least understanding what Simulink does, we want a blank model, right? So a blank model tells us that we will need to have a very clear starting point of what we are trying to achieve. And what is that exactly? What are we trying to achieve? What we are trying to achieve is first an understanding of the different options that Simulink gives us so we can maximize this. And what does that give us? Very important. Simulink works with libraries. So there's a library browser on the top panel that gives you different types of options. And the one thing that we will do now is give a very clear indication of just how one goes about simulating anything. So the first place where I would go is essentially go to the common use blocks. For example, in this case, we will have something like, we will load specifically the data that we have directly. And one way to actually look for it is to do something like load, and that will search through the whole library. And for example, it will give you a sense that you can load directly from file. This is quite useful because in this case we are able to load directly from a file, or specifically a mat file, and that mat file will allow us to not only visualize but start doing different things with it. So whatever is on the workspace will be able to load up, or whatever is stored within your file system can be loaded up by Simulink. And go here and double click, and or you can either also do this, right? And it will go to that folder and select what you want exactly, and then click apply. Given that I'm loading up data with 4 variables, I will need to be able to demask it. Demask just means I know that my variable or my data has more than one signal. I would like to split it up into different signals so I can see what's inside. In this case, there's 4 variables in there. That's essentially what I want, and I would like to then now connect each and every single one, and let's see what the first one gives me. If the data that you saved is non-compatible to be loaded up directly in Simulink, you have 2 options. You have the option of directly not use the data, and instead, or the data that's saved in a MAT file, but instead you go back to what we call sources. So we talked about sinks. Sources is essentially inputs, a set of inputs that you can put in. In this case, I would like to load up a specific variable, this block that is called from workspace, and from workspace is down here. From workspace essentially means I can load up any variable that is here that I can use directly for my simulation. So in this case, what do we want to simulate? We want to simulate the electrical power that's noisy. So what we can do is take this variable, double click here and say this is what we want. But what do we want? We don't want the full matrix, so we want maybe only the first row. So let's say we want the following. We want the first row, but all the columns. And this is how you write in MATLAB. And in this case, we don't need Dmux directly, so we can delete that. And we can directly put this into a scope. What that gives us, let's have a look. And we simulate this. It's taking some time. Okay, there you go. Now here is very interesting, right? So the one thing that you need to remember is that this is a variable that came from MATLAB. So if you do not know what is in the variable and you want to figure out how to make it work, the one thing that you need to figure out is what is it doing, right? So what is it trying to do? And clearly what it's trying to do is it is loading up only the first value. And all of a sudden what you need to be thinking about is, have I saved the variable in such a way that I can easily simulate it in Simulink? In this case, the answer is no. So the only thing that I would say one can now do is to essentially say, can I replicate the signal myself, right? And this is kind of the third option. We went from loading the mat file to a singular value, and now I'm going to show you a specific way of simulating. Now, there's a couple of ways of doing this, and all of this is down through the different things that are available. So in this case, I can simulate a sine wave. And this is quite important because a sine wave essentially allows us to simulate a couple of things. One, it allows us to simulate periodic, events, but also allows us to simulate what we believe consistently happens throughout the day. And this is in the case of solar energy. So you can get to a point where if I were to put in a very low frequency of, let's say, half radians per second, and I were to now say I want a specific amplitude, and that amplitude could be, I don't know, could represent kilowatts, could represent hours, could represent intensity, whatever the case may be. And all of a sudden, what I can do with this, and I put it on the scope, and then the scope gives me what I want. Now, not necessarily, right? Now, this is quite important because what we see here is we see something very similar to an intensity, at least on the positive side, but all of a sudden we see a negative side which we don't want to see, right? And that's something that we can definitely fix. But the point is to get the understanding and the power of going from lines of code that essentially need to be coded in to all of a sudden getting to a simulation that the only thing that you're doing, even though there's numbers, you are fundamentally going into a graphical world. And this is the power of Simulink. This is the power of going from having to debug lines and lines of code to now coming up with a clear understanding of how do I want to structure my simulation.